Welcome to Zero Knowledge, a podcast where we talk about the latest in zero-knowledge research and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
This week, I catch up with Illia from Near to talk about what's new in the network since our last conversation last year. We also chat about the long and challenging road to launching a POS network, sharded versus non-sharded blockchains, and Near's plans to provide an ideal spot for blockchain developers. But before we start in, I want to say thank you to this week's sponsor, Trail of Bits. Trail of Bits has published a guide for building secure contracts with their Crytic offering. Crytic is a SaaS-based GitHub application created by Trail of Bits. It continuously assures that your Ethereum smart contracts are safe and functional. It reports build status on every commit and runs a suite of security analyses so you can get immediate security feedback. Check out the guide, which I've added in the show notes, for tips on how to build security into your dapps from the start, as well as how to use the Trail of Bits suite of tools for automated vulnerability detection. So thank you once again, Trail of Bits. Now here is my interview with Illia from Near. So today I'm sitting with Illia from Near. Illia's been on the show before with his co-founder Alex last year. You might want to check out that episode where we talk about, how they got from where they were to Near at that point. Welcome, Illia.
Thanks for inviting me. Hi, everyone.
In that show, we actually did talk about your background. We covered sort of the work you had done before at Google and how you got started with Near. So in this episode, I think what would be really interesting to hear is what's been happening since then. We're now a year later. What's happening in the world of Near?
So, there's a bunch of stuff happened. There's a world stuff, right? Obviously, everybody's living through a kind of devastating epidemic around the world. And it did affect kind of in one ways. Obviously, there's a lot of negative sides, but there's also a positive side, which is kind of our team and everybody around the world, right, went kind of into decentralized mode and really everybody's more interested in what's going on online and what's where they can find a community and work together to something that really changes the world.
That's a really good point that it's true that this has really turned what was a decentralized focused industry, but we'd still all meet in person and often offices still existed where everybody would get together. Now it's even more truly decentralized with even if you live in the same city as your team, you're actually going to be working from your little pod, which is your house. And people have gone to they've gone back to their parents' home or they've gone back to their hometowns because why stay in these centers? It's super interesting to think of it that way. What else has happened, though, in the world of Near? The big change has happened, right?
Yeah. So, we went from kind of discussing how we're going to build to, having the protocol launched. So, and pretty much now having developers and community building on top of it.
So you launched the network. How has that been?
It is very freaking hard. I think we've repeatedly miscalculated how much work it is, right? Even there's obviously a technical work and we've built from scratch a lot. So there's been a lot of kind of just work making sure that all works. But then after that, there's obviously community piece, there's economics and token distribution piece. There is kind of regulatory, foundation companies piece around that as well. And kind of all of that together, right? You always kind of underestimate how much work it is there, outside of what you think you're already doing. And there's part of it why every single protocol has been late, right, from the original kind of expectations. But it's a lot of work, a lot of sleepless nights, especially given I'm in Shanghai, so the time zones are hard. But
they're different.
Yeah, really kind of pushing forward has been. It's fun and exciting because you're actually building something that's affecting the whole world and runs around the world, right? But at the same time, there's a lot of kind of small details that need to come right for this all to work. I think in last episode we talked about how much we evolved since we started, right? So last episode was about a year in, And I think we changed our protocol at least like 3 times by that time.
Since then or by
no,
then?
By then. And big part of it was
Yeah.
like we started pretty much like we came from building kind of, centralized solutions, like distributed but centralized solutions. And obviously, decentralized space has a lot of its own challenges. And really a lot of it was been learning and kind of, researching and working with other folks on this. Since then, I think most of the design is the same. There's obviously a lot of like small details that kind of got refined as we built them. Some details are actually still getting refined. Like, I think it's the same as any protocol in reality is like the work is never done, but like the kind of the high level construction is pretty much the same. It was built like last year, and then like since then it's pretty much been in testing and then production over time.
Cool. In that episode, we actually did a comparison of like sharded blockchains. We talked about sort of the different ways that they were built and how Near is built a little bit differently, where instead of having something like a relay chain or a beacon chain as a central point between equal chains, it is mainly that beacon chain or relay chain. Is that still the case?
Pretty much, yeah. So like conceptually it's just one chain, and then each block is kind of sharded. And so this, like, among other things, allows to like increase and decrease number of shards somewhat like easily. I mean, obviously, like there's a lot of like technical issues, how to do it, but because from perspective of a user or a developer, this is just one chain. They don't need to think about sharding, right? Mm-hmm. And so all of the kind of complexity is being handled on like layer deep, right, on infrastructure layer. And it's kind of been like our like design principle is that we're trying to hide kind of a lot of like blockchain complexity from user and developer. And sometimes it's actually like backfired because especially when we have crypto developers or crypto users who are familiar with like Ethereum coming in and they're like, wait, but where is my, public key or where is my address? And it's like, well,
like the things they're
actually,
used to.
Yeah. They're used to the things, and like ours kind of works more like regular stuff. And
like
so
Web
sometimes
2.
we need to give them a little bit more. Like for crypto users and crypto developers, we need to give them a little bit more too.
That's
which
so
is
funny. You almost have to diminish the UX experience so that it feels real.
Yeah, exactly. Yeah, like wait, where's my keys? Like, how do I know this is like crypto? It's like, well, I mean, you can go into Explorer and look at like, dig in and like, yes, there's shards there, but like, do you care?
One topic that's come up like just a few times in the last month or so on this show was just this question of data availability on the L1s. I know that in the last episode we actually did touch on it, but I don't know. I don't really understand how data availability works or will work in Near. Do you mind actually sharing that with me again?
So the idea is that, so let's say you have, for simplicity, you have 100 validators and you have 10 shards. So there's 10 validators in each shard. When they get the transactions for their shard, they split it in 10, we call them parts, and send it to validators in other shards. So the construction that's used is called Erasure Coding. And so this is a construction that if you take some piece of data and you can encode it in n parts, and 1/3 of that parts is enough to reconstruct the whole original data, right? So this is kind of a way that's used like for data reconstruction, for signal reconstruction. And so this is used by us and Polkadot and Lazy Ledger and a bunch of other people in this crypto space. And so what this allows to do, right, is that even if one shard is malicious, even if, like in our case, we rely, even if 1/3 is offline and 1/3 is malicious, you can still recover all of the data from all the shards from the left 1/3 of the validators or of the stake.
Cool.
And so this provides the data availability for all the shards, which means that even if something went malicious, right, even if like because it's a smaller subset of validators in your shard, you can always reconstruct the data and prove that thing went wrong and kind of roll back the whole chain. And so this construction, again, it's very similar to how Polkadot, for example, does that specific piece. But in our case, because it's kind of considered one chain, we actually embed this property directly into the chain's consensus.
Oh, wow.
And kind of chain rule. So which means that the chain that has been built, like by definition, it needs to have this property of data availability. Otherwise, the people who don't see the available data, like who didn't receive the parts from other shards, will just not accept the block until they receive this data. So, which means like the kind of as chain been built, you know that because people built on top of it, right, and they approved the kind of the block itself, they have all the relevant data for this thing. And so kind of the data availability like properties are the same as the properties of kind of security of the chain itself, which is a little bit different actually from I think like what Polkadot properties are on data availability, and definitely different from, for example, even Ethereum data availability. Like, for example, rollups putting data on Ethereum 1, the attack cost is actually a 50% attack, right? Because you could just fork off the chain from a different level, right? And so this means that the kind of properties of data availability are actually like their cost of attack is different from the kind of cost of the itself protocol.
Like the security model, I guess.
The security model is different. Yeah, so we try to align all those models together of like the security of the protocol, security of of data availability, and everything into kind of one property that people can like reason about.
Do you actually envision a roll-up type system also existing on Near though? Because I know with if you look at the ETH roadmap, the idea of roll-ups also being kind of a permanent feature of an end game. Do you also think of it that way?
So I actually, like what we've built and actually what Polkadot built, I actually call it a realistic rollup, because what happens is like this shard, or in case of Polkadot, a parachain, they kind of run this as an operator and they send it to the, like in our case, to everybody else, or in case of Polkadot, to the relay chain. And that relay chain executes it right away and verifies that this block is correct right away and acknowledges it that it's good, right? And like in optimistic case, you wait 7 days, and this is realistic case. You just run it right away and say it's good, and now everybody can use it, right? And you can have cross parachain or cross shard communication right away. So from this perspective, like this is, a roll up, and that's what I'm saying. The properties underneath are actually very similar that you get.
Wow.
Now, the zero knowledge has a different properties. Zero knowledge rollups have properties of zero knowledge of like, first of all, scaling the computation a lot more, and privacy, right? You can actually execute some on data that may be not available at the moment.
Sometimes, not all of them do.
Yeah. It's like the problem with zero knowledge rollups is like it's a very like it's a big space of a lot of stuff you can do.
Yeah.
So that I think is actually will exist in its own right, because there is so much more use cases you can do that. Like it's not your normal kind of, receive transactions, execute, post it on chain, right? Like there's a lot more stuff you can do, including you can actually have a realistic kind of zero knowledge where you put transactions on chain first, and then you execute zero knowledge and commit to the result on chain. Like right now, zero knowledge like rollups, because kind of the transactional throughput of of Ethereum is not enough to like accept transactions. They would accept transactions on their own, but it's actually not a good design, because that means you have kind of a centralization point of receiving transactions. And also this has actually some potential legal implications, right? Because they may be like, it's similar to if like a centralized exchange receives, trades somebody's money and then settles on chain, right? Like centralized exchanges are enforced on what they can do and what they cannot do. So like actually rollups potentially, right, if the number of operators is too small, may get into the same problem. But if you use a kind of on-chain data availability first to like collect transactions, you don't need to execute them, because maybe the data is actually like just a commitment hashes. Like you don't reveal the data you want to execute on, you just reveal the kind of desire to execute on and the ownership. And then the zero knowledge kind of operator pulls the data, runs it, and then commits to the state and commits maybe to the result. Like that kind of system is very interesting, because it allows to do like, dark pools and kind of dexes and all this new stuff in a very like kind of censorship resistant and private way.
How does that operator though, like, so you just described it, like the operator's still there. Why is that no longer a point of centralization?
Because any other operator can do the same job, right?
Okay.
Like it's a very different where like I need to send transactions to this IP address or whatever, to this domain, and I send transaction to the chain, right? So any of the nodes can receive it and agree on this is a transaction, and then any other operator can do the kind of the like private execution.
I see.
And like at least from my perspective, I mean, again, like we don't know what the legal requirements, etc. But like from my perspective, in this sense, right, like I can run an operator, you can run an operator, right? And like we can kind of like whichever operator gets it first and executes it, right? That's the one that does it. Like there's, also like SGX stuff that can be used. But yeah, from perspective of like, what, for example, right now, like if you're doing Starkware, right, you need to send transactions to Starkware, right? That they will be receiving them.
There is a committee somewhere in there as well, and it's multiple.
Well, there are committees for data availability. There are committees for data availability post factum.
Oh, yes,
it's like after you commit to the result, but like so sending like somebody needs to receive transactions. It's either a decentralized network or a centralized kind of entity.
Yeah.
Like there's two options. So they either need to build their own decentralized network to receive transactions and agree on commit on them.
What you just described as those operators, they almost start to take a role, like they have to be incentivized somehow to do this. And so they're like sub-validators or something. You've talked about like the validators that are also going to be existing on various shards. Could these be the same roles? Or like, do they have to be independent of the system?
So they don't need to be. So this is idea of like off-chain workers, actually.
Okay.
So this idea of off-chain worker where the job is like committed on chain and paid on chain, but you do some work and you commit to the result like on chain, but you do the work off chain, right? So it's not, you don't need a committee. And so zero knowledge, like provable work is actually very well suited for this because you don't need a committee. Like the result itself is a proof that you've done the work correctly, right? So that is a really cool thing because from my perspective, it can be like a piece of software that reads from the chain the input and what it needs to run, executes it, and then commits to chain back what it does, right? So then anybody can run this worker, and there can be like pools of these workers, and yes, validators can be running this job as well, but it will be kind of a separate service. You can set up this thing for pretty much anything, right? In theory, you can have like a MapReduce job where everybody's like pulls some different pieces of data, executes, and then commits to the result on chain. And like you cross-reference that, the job is actually done correctly and, the results matches.
Do you have that role, the off-chain worker? Is that something that Near would actually build, or is that just something, is a concept that exists?
So we haven't published this yet, but we're actually working on like a 5-year roadmap. Whoa. Which is not just for what we're building, but like what the ecosystem should build. Including a bunch of like different applications of kind of open web, right? And so this includes like the off-chain workers and like off-chain storage is kind of pieces of that like ecosystem because they will be powering kind of this new use cases. So for example, NewCipher is a really cool thing. And they took them, 2 years, I think, to build it because they needed to build their own infra for these off-chain workers. So if there were existing pool of off-chain workers, their work would be just to put a contract to do like the same contracts they have right now, but also just write some piece of code, piece of WebAssembly that everybody can run.
Yeah.
But like they needed to actually run their own test nets. They needed to do all the stuff because they built the whole stacks themselves.
Cool.
And so the idea is like to have this kind of common infra that would pretty much feed into it, right? And use like different pieces of infrastructure.
Man, this is so interesting to hear NewCipher put in that context. I didn't think of their role as doing that, but now I'm like, oh, that's like, because I always learned about the tech. I didn't really understand how it fit into everything else, but that's really cool to hear. I wanted to ask you something else about sort of the general system. Stateless clients, this is something we just on the last episode had Aline on, Aline Temescu, to talk about this kind of research into stateless clients. And I just wondered if you're thinking about that, if that's also research you're paying attention to, what that would actually mean for Near.
I've been having actually these conversations because I actually got a little bit into some discussions on Twitter about like ETH1, ETH2, and so I've been talking with some folks who are working on this, and we also have a episode of our whiteboard series about TurboGeth on related topic. So I think like stateless clients are actually really great from a protocol developer side. So as a protocol developer, stateless clients are great, amazing, because you're actually removing a lot of needs from kind of on the side of a protocol, and you kind of pushing it all on somebody else to deal with, right? The problem is that like as a developer who wants to build on top of the protocol, as soon as I start thinking about like, well, how am I going to handle this? It becomes like super complicated because it means that somewhere there needs to be like data available, right? We go back to like what does the data availability layer looks like. And on top of it, it's not just it needs to be available, it needs to be really fast. So like kind of the on-chain data availability, the reason it's fast is because all those people are super motivated, otherwise they're going to get slashed, right? But like as soon as you say, well, the validators actually don't care about data anymore, right? They just like, you just receive transactions with all the data they need, they execute it, and they're done. On the side of like developing this client and protocol is easy. And it also removes big chunk of like economic issues, which is like how to charge for storing data on chain. Mm-hmm. But now you have this whole like this problem didn't disappear from the ecosystem. You just moved it to somebody else to deal with, right? Mm-hmm. So now you have like things like, for example, let's talk about ETH1. Let's say ETH1 transitions to stateless world. Now you have Infura, the graph, like all those systems now still need to maintain the data because they will need to still give data to their users. And so now they need to do it. And if they go down, which, they do, well, everybody's completely like screwed because like where else are you going to get data? You cannot go to miners anymore. They don't have data. Like you really need like one of those guys to actually work. And so obviously there'll be archival nodes which will have data. But again, like there's no, like we already know there's no motivation to run archival node in the first place. So the only people who run archival nodes are Infura, the graph, and like other kind of data providers. Mm-hmm. And so you kind of, like you remove this problem, but I haven't seen at least yet a solution for this problem on the other side, right? How the users will be getting access to this data, because to send a transaction now, you do need to get like all of the like Merkle path, right, to your balance, right? For example, even in a simple case, like I want to send you some ETH, I need to get like a Merkle path to my account, right? So I need to maintain that information, somewhere I need to pull it from somewhere. So part of like I'm trying to get in more with some folks who are like working on this personally, and also our team is talking. But I think like it's not yet like fully thought out from perspective of like how it will affect the whole ecosystem.
Yeah. And also just going back to that episode from last week, we actually did make this distinction between stateless clients and stateless validators, or validation rather. In what you just talked about, would you also put stateless validation in there? Like, or is that a sort of different angle from what we just...
I would say stateless validation is what you want, because the reason, for example, we cannot change number of shards dynamically all the time is because validators need to get state, right? Like I'm like what I'm saying, like if we went stateless, it would solve so many problems for us. Like we've thought about it, right? And we actually have all the stateless like client stuff built.
Yeah. Because
challenges are actually validated in a stateless manner. Like you send the transactions and you send the state affected, and we can validate this in a stateless manner, like across the whole network. We already built all that. The problem is if we just if we shift to that, then like, well, who has data, right? So there is like there's this missing piece, I think, which I'm actually interested. Like maybe Ethereum, there's some folks in Ethereum who already sorted it out. So like I'm really interested to learn from them in this case. But I haven't seen yet like a clear plan why, like what's the motivation to maintain this data kind of somewhere else and also serve it, right? In a way, it's actually like something like Filecoin, right? Or like some data storage solution may be like closer to how then this needs to function. But then like Filecoin, serving data in Filecoin itself has a lot of problems, right? You need to pay for it to get data. Well, how do I pay to get data? If to pay, I need a data to send a transaction. And it's like, anyway, there's like a lot of this kind of interesting questions, like how to design this in like really working way.
Cool. I had Anatoly on from Solana with guest host Georgios also a few months ago. And he had this extreme anti-sharding sentiment. And as like a team that's very focused on sharding, I always like, because we had that interview and I left it. I haven't had a chance to really revisit that, but I want to hear sort of a counterbalance argument from you. I'm sure you know his argument, right? You are friends. You guys,
we worked across the road from each other actually in San Francisco. So, I think so. There's like a snarky answer, which is if Anatoly is right, then the mainframe is enough to like one mainframe is how Google and Facebook should be running their infrastructure.
Okay.
Right.
But experience proves otherwise, I guess.
Yes. There's kind of two conceptual reasons, right? One conceptual reason is that, yes, you can rely on like a very optimized, pieces of hardware that like can kind of scale up in big ways. But this piece of hardware will always be expensive, right? And kind of his point is like, Moore's law, double every 2 years. And like, but the bleeding edge will be super expensive. Not a lot of people can afford it. But also you need like very fast network, like the fastest network possible. And on top of it, it's still only double every 2 years. And kind of, if you think from like Facebook adoption, Google adoption, like the adoption we want, right? Not adoption we have right now, sadly. Like we don't want double every 2 years, right? We want, like 10x in a year, for example. Right? Yeah, or something. Like we want, billions of people using this. And obviously the billions of people cannot fit on one computer, at least like not in the foreseeable future. So that's kind of one side. And it's kind of like there's a usage on one side and there's centralization on the other side, right? The centralization part is like there's only that many people who can afford to run this hardware. And so sharding solves this problem, right? Sharding says like, well, we will run on less sophisticated hardware. Like it's still, reasonable hardware, at least right now. Well, with stateless validation, it can be actually less sophisticated. But we can actually scale up, and we also don't need to have everybody like receiving all the transactions all the time. So you don't need to have huge bandwidth requirements either. And instead, we kind of scale out. So that is like one part. And the other part is actually very interesting, which is like Solana is actually different from how Ethereum built. It's different from how other like one chain networks built. It's actually built in a very similar way as we built it, because they want to parallelize as much as possible, right? They want to use all the hardware, which is a lot of CPUs, which is a lot of things. And so Ethereum is actually not built like that. Ethereum is kind of one process running stuff. Solana parallelizes execution of multiple contracts. Otherwise, you cannot achieve, actual performance with like more CPUs and more hard drives, which is actually what sharding is. Sharding is literally parallelizing stuff. Yeah, it's just like it's done on one machine instead of done on multiple machines. And so the kind of like all the issues like we have on the kind of like composability and some other like and how users need to like work with the stuff, they actually have them as well.
Mm-hmm. It almost sounds like the parallelization moves up a level in the sharding system.
Yeah, exactly. Yeah. So we're just like, well, if everything's parallelized, how do we solve this, right? And like the interesting thing is like we can say, well, let's just run all shards on the same machines. Like all machines run all shards, and then we kind of get Solana to big extent. And then so we actually have this like the way we're rolling out sharding is so we start. I mean, we can go into that a little bit more, but you can actually like in reality say, well, some shards will be running together. Right? It's just like they need to run on more sophisticated hardware, and some shards can like scale out, right? And so in this way, you can actually combine this like different like requirements and different environments a little bit while still maintaining like the same developer experience.
Are are the shards homogeneous? Are they identical?
Yes, and soon no.
What?
What?
Mind blown.
We started with everything's homogeneous, and actually, like the interesting thing, because the way we actually shard blocks, there's an interesting like mind shift. You can think of it, every account and contract on Near is its own shard. And instead, we group them into batches for optimizing processing, right? So if you have your own contract or your own account, it actually lives on its own shard. And then we just group them, kind of batch them in a way such that, you don't waste resources, right?
Yeah.
And so that's the idea. Like the block, every transaction kind of comes into its own shard, but then you just batch them to execute them.
Into the shards that you kind of described.
Into
as
the shards, into the actual like physical shards, right? Yeah. And so and from perspective, like Solana actually works kind of the same way. It's like every contract and account is actually runs in parallel, right? And then they're just like batched. You can think of it as they batched on one machine. And now that's why we can actually change the number of shards very easily. We just rebatch where the accounts are on what shards. So this is very different from how, like, for example, obviously like Polkadot but also any other, like most of the other sharding networks think of it, because you have like pretty much in other sharding networks or in Ethereum 2 Serenity design, you kind of have an account on every shard in a way, because you like, and you need to send money to yourself on the other shard and like your wallet needs to show it somehow. And it's like super complicated, like for a user. Like now I need to think of like, well, do I have money on that account? Do I have DAI on that account if I want to like, use Maker on that shard? And like, do I need like, so we kind of removed all that. We said, well, like from a user perspective, like you don't need to think about it. You just have one account. And we just say, well, the contract cross account communication, all of this is a cross shard communication, even if they're right now in the same shard. This allows us to rebatch things, and it kind of makes everything in a way homogeneous because like everybody runs the same thing. But now the interesting thing is, well, actually, because each contract is its own shard in a way, you can say, well, one contract will be something else. So for example, we're going to be launching EVM as a contract on Near.
Whoa.
So EVM, like Ethereum virtual machine with all the accounts and contracts, will be launched as a one contract on Near. And so inside it, you have all this like Ethereum contracts and accounts and everything, right?
Yeah.
And like you can think of it like we're launching.
And then
like,
on top of that, you'd have Solidity code running. So you basically have Solidity code running
so,
on of EVM on the actual, okay.
Exactly, yeah. Yeah, and like you can think of it as actually, this is what Polkadot is. Like your one substrate chain is really just one contract that then runs on relay chain. Like your parachains are just contracts that run on relay chain. That's kind of
and then the parachain could be like EVM compatible.
Exactly, or something else, right? So this is what we're launching right now is like EVM is, and so it actually will not be its own like physical shard right away because it's not worth it, right? Right now we will not have in the beginning enough processing, but as it grows, as usage grows in that EVM, it actually can pop up into its own physical shard. So it depends on the usage, not on how we want it. But also this means that anybody else can say like, well, I want an Oracle shard or whatever, and you deploy a contract that does that, and then maybe like we are thinking about adding like ability to prepay for some specific gas limit. So that you say, well, I want this much gas be like allocated for me. And then, so based on that, you may allocate it like into its own shard or like into its own like, mini shard.
Are the shards specific sizes? Like, is there a limit to the size of a shard? And so you could almost like buy the entire one?
Well, yeah, so that's kind of the idea. Is like each shard is really like what we benchmarking is. So we want like 1 second blocks. So you need to execute like within like the shard execution should take like 0.8, 0.9. It's like it tries to balance it so it fits plus data distribution, everything. And we have like obviously gas estimation for everything to kind of how to fit time on basic hardware to the execution. And so this is kind of your limit how much one shard can have. And so into this we kind of package all the contracts that can fit. And yeah, so you can say like, hey, I want like whole shard for myself. So we don't have this implemented yet, but like it's kind of like our system allows to do that because you can just say like I want to prepay for this much gas for my contract or set of contracts, and then like when you send transactions to those, right, they'll kind of go into its own like physical processing. And so this is very valuable for oracles, for example, because oracles don't want to be kind of squeezed by somebody else, like even intermittently. And so they may prepay, like they don't need like a full shard space, but they may prepay for some amount of capacity to just like always have enough processing.
Okay, so I think now would be a really good time to go back to something you teased out at the beginning, this idea of like, you've launched this new network. I want to hear a little bit more about like what that means for Near. Like what is launching to mainnet? Do you have this entire system like ready, poof, presto? Are there steps? Are there stages?
Yeah, so we actually had already a bunch of stages and probably going to have a bunch more.
Or phases.
Yeah,
what do we
phases.
call them? I think it's
phases. Yeah, phases. I think it's been a thing now. So one thing is like launching network is super freaking hard. Like there's a multiple complicated parts. And I would say we also like, I mean, we underestimated how much work it is multiple times, to be honest, right?
Okay.
Like, we're like, okay, now we know what it is. And then like, no, that actually there's a bunch of more work that you didn't think of. And so, yeah, I mean, this is a big part why I'm like it's so hard to launch networks. Even if you have all the code ready, it's so much easier to just launch an app on an existing network. So, I mean, this is like this kind of, like I've been having
this is a warning to all those L1s that are coming up.
Yeah, L1s, but also like people who are trying to like, launch it, like it's their own Cosmos network or even Parachain is like, yes, like the framework solved a lot of problems for you, but there's still a lot of more work that's kind of there to do to get it off the ground.
Would you say most of that is like lives in the community side of things, or is that like a technical challenge?
There's technical, there's a kind of economic, community, communication, like technical. I mean, obviously, like we built all of our code base from scratch, so there's a lot of technical thing which kind of we got ourselves into. But then even after that, right, if you think of it like just coordinating a bunch of validators and getting them to be like running the same software, making sure that everything works, networking, firewalls, all the stuff. And obviously like now we have like this layer of professional validators. So let me walk through kind of, how we've been launching, right? So I think like kind of a general practice now is have this like incentivized testnet. The first time we started this was actually like end of November last year. So like a year ago. And so it was like a stake wars kind of idea. We wanted kind of validators to like battle against each other and try to find vulnerabilities. And what happened is our software was not ready at all, right? Like it wasn't about battling against each other. It was like, can we get this stuff
getting it to
run?
work?
Yeah. And the part is like in our kind of, it's not like we were like, hey, we wrote some code, it's ready to go. No, we had like a bunch of testing. We had our own internal networks. We had all the stuff and, it seemed like it's ready. But like the real world is just so much more unpredictable than what you have kind of in the lab. And so we actually stopped our stake wars and we said like, okay, thanks everyone. This was very informative. We're gonna take the time back to like actually like analyze and find the core process issues in our kind of way of doing things. And so this led to like multiple changes on kind of how we do software development, like pull request reviews, how we do release process, how we do testing, and kind of what kind of testing we do as well. And so this, like we kind of revamped the whole process and restarted, like, I mean, with that, we kind of fixed a lot of problems and found a lot of problems and restarted Stake Wars again in like February, March this year. And so with that, it actually worked way better. Some people were like, it works too well. Like, well, why are you guys launching so late? But
you had learned a lesson that there was these edge cases you had to really try out for. You had to really look out for.
Because, I mean, one of the things is like, if you have like very like non-baked software, you get a lot of the same problems all the time. And it actually stresses people out. Like, kind of that's actually developing, right? And it's really hard to like communicate around it. So now like with kind of very straightforward process, it was like very easy because we're like, well, we're going to be like hard forking the network every this much. So like if there's issues, if network stop, it's like, okay, fine, we're going to restart. And like this is also like lessons learned, obviously, like from Cosmos ecosystem. So like Zaki's recommendation, etc., been kind of incorporated into this. So that started, and even then there was a lot of like really funky problems that kind of came out. Right. And so each funky problem we saw, we kind of incorporated it into our like lab testing. So we have this like, we call it the NADAC, a testing suite. There's like 120, 130 like scenarios. And so this is not like unit tests or integration tests. This is a full like cluster, spinning up a cluster of nodes and doing something with them and seeing that everything works. So it like, you spin up a cluster, you send malicious blocks, you spin up a cluster, you drop nodes, you restart nodes, you like hammer them with transactions, you like do all kinds of stuff. You change epochs, you kind of remove validators and like add validators, all those like scenarios.
Is this something that you built or is this something that's standard? Is this like an existing tool set?
We have built this. This is actually Alex's experience from MemSQL.
Oh yeah.
Which we should have adopted way earlier, but it's good we adopted. I think it's a standard thing for like in a centralized development environment. And I was actually surprised. I've been talking with like Open Ethereum team, and the Ethereum actually has a version of this, but it's kind of, it doesn't seem like it's actually being like fully used. So actually super, like I'm going to put some bounties for people to use NADAC, to use our infra to run Ethereum clients on it. to test kind of their scenarios as well.
Interesting.
Because I think like this is very powerful framework to kind of test this like very complicated setups. I think like they have this for ETH2, but actually for ETH1, like Ethereum Foundation has a framework, but like I don't think it's been like exercising a lot of the like kind of more networking level problems. Like I think that the frameworks they have right now is mostly for consensus part. But anyways, but this idea like it actually helped us a lot, right, to kind of standardize how kind of developers can test, like can get like battle tested their code before submitting it. And so it helped a lot. But still, we had all kinds of like random weird stuff happening. Like one of the validators had like some CPU instruction missing on their like somewhat new CPU, and that led to like a fork of the network, right?
And all the edge cases you're going to have to think about. My goodness.
And then we also had like upgradability so we introduced upgradability. It came kind of late. Like we were already like during this process, and like we were pretty like stable. And so we introduced upgradability because we were like, well, as we launch mainnet, right, we will want to continue evolving the protocol, and it's important that like it's pretty easy to do, right? And so we introduced kind of like a protocol level upgradability, and that on its own led to a bunch of stuff because actually like we haven't really tested it well in this lab. And so when network upgraded and like some people didn't, and then there's like, all kinds of fun stuff that happened. So a lot of this like edge cases and random weird stuff that happened, that what we did, right, we just took it and we implemented it in this NADOC and just like kept building up the library of this like kind of stress tests for the network. So that's been like the kind of summer, let's just say. And so with that, right, we've had kind of we call it the BetaNet. So BetaNet was our network where pretty much it was hard forking all the time. So it wasn't for developers, but it was for validators to like just really hammer at it. Like we had 100+ people like hammering at it all the time. Like it was professional validators, but also like a bunch of people from kind of community who came in who was like, hey, I want to figure out how to run nodes. Let me try it. And so like learned a lot, figured out a lot, and then kind of we transitioned them to like our official testnet. So our testnet, actually, the interesting history for it, this testnet has been running since April 19. So it's the same network that's been hard forked and upgraded into what it runs right now with not changing state. So like if you deployed some contract in April 19, it's still there.
Still there. Wow.
And so it took us a lot of work to make that work. But so because of this, like we had like a group of developers who've been developing on Near, and so they've been kind of using this testnet. So we introduced kind of validators to that network, and like by that time everybody already learned kind of how to do the work, how to validate, what is all the kind of like we have smart contract staking, so it's like a little bit more interesting but also complicated for validators. But so this is like, then we ran testnet for a while, making sure that operates properly. And so then in parallel, actually, we launched a proof of authority version, or like kind of permissioned version of mainnet. And so we did that in like end of April, beginning of May. And the idea was there's actually a chicken and egg problem of a lot of tooling needs mainnet to start being built. And at the same time, we needed a lot of tooling for mainnet, right? Like a wallet, Explorer, all of the stuff, right? We wanted to test it on mainnet, but like it needed mainnet to be tested, right? And like, some
Why
custody
does it
solutions. Need
mainnet to be tested? It's like, couldn't you test that on a testnet, like all the accounts and all that stuff?
Yeah. So we tested everything on testnet, obviously, but like for a lot of like actual, real stuff, you still want like still kind of acceptance testing on mainnet, right? And the same thing for like token distribution, like some of the like kind of other stuff, because like obviously some accounts are different, the keys will be different, all the stuff will be different. So we kind of like launched this POA so we can start like getting some developers to like really deploy to mainnet and actually test everything.
Yeah.
And this still was like kind of operated by us, and so there's a lot of constraints. But what it allowed us to do is actually not needing this like, oh, today everybody's starting mainnet. It was like, now that you know how testnet works, you can actually onboard on mainnet. So we had like the slow process of validators coming in through pretty much August, September. And September 24th is where we stopped validating completely mainnet, right? So it was kind of not like a step function where it's like, okay, today, everything launched. It was like a smooth function where it's like, started with like near foundation, and then over time, like all of the validators were kind of external.
Yeah. And I should say, like, the zero knowledge validator, which I've mentioned a few times on the show, is a validator on Near. And that is actually where I started to see more about the Near network. It was probably like, earlier on this summer. So I did see a little bit of beta net to testnet to mainnet. I guess this is the big challenge for the rollout, is having, has anyone tried, I don't know if Cosmos did it this way, but like, has anyone tried to go straight in, like launch mainnet with validators day one?
So I think like everybody's in recent days, like maybe like in 17, beginning of 18 is different, but like Cosmos, Polkadot, and us, we all launched with kind of restricted tokens. So we did not allow to transfer tokens, and we gave this decision to the community itself. The Cosmos did start with like already a set of validators on day one. Us and Polkadot have kind of ramped up into it.
Version 2.
Yeah.
Public, yeah.
And Cosmos, big reason is like all the Cosmos been building this validator community for 2 years. So like to big extent, like us being able to build it like quicker is the reason, because Cosmos already paved a lot of work.
Yeah,
for a lot of us, yeah. And so they had like this people who are kind of were ready to go, and they've been doing this for 2 years, and like it was like on day one they had all of them kind of ready to go.
Yeah.
In our case, yeah, we kind of built them up like and trained them, and big part of it, like our system is pretty different. Like we have different account model, we have smart contract staking, we do have sharding. Like there's like some other stuff that's kind of like interestingly different. And it was like really good to have like people kind of test everything before they, like I think like if we tried to launch it on day one, it would have been like a pretty dramatic like mess.
Yeah. No, definitely there was like these small steps in like educating the validators as they go. As you were rolling it out, there were like parts that we had to do to get on board. Let's talk a little bit about like building these validators, this group. How did you go about putting that together? Was it like existing validators? Like what was your thinking around it?
Yeah, so it was, as I said, like combination. It was existing kind of professional validators who already been doing this on like Cosmos. Some were doing this on Teslas. It's a pretty small community at the end, right? So we like connected to most of them one way or another. So we kind of been talking to them before, and we just invited them to this like beta net when it started. And at the same time, we made it open, right? So we said like, hey, anybody can apply. We actually had like over 300 something applications when we just launched it. And so this like big part of it was like this professional ones, but also like there's a lot more people who are kind of like, I'm a, like a developer who's interested in this stuff, or I'm a developer, but I've been validating some on some testnets, or I am validating one other network. And so this group of people, they were kind of, I would say, newer to the validating in general. But at the end, like, they gave a lot of feedback as well, because they were people who are maybe less, like they're newer, so they have a fresh eyes, so they can give kind of more. And also they were running like all kinds of different hardware. Like, as I said, a lot of people running in cloud, but a lot of people were running like dedicated hardware with like all kinds of random things, like Docker is not working and stuff like this. There we had like this set of challenges where kind of through doing them, you kind of learn how everything works, and you also write documentation or tutorials for other people to learn. So it's kind of like
training by fire.
Yeah,
is that what it is?
Training by fire. But also like the thing we're trying to do is find these people who are excited and willing to do it, and use them kind of as an amplifier, right? So like I was mentioning this like a fractal model is. I think like obviously like as a kind of core team, and as now network launched, kind of our role is still pushing some of the infra stuff, but at the end it is network of the community. So we want kind of in a community people who around whom there will be kind of keep growing the network, and ideally it will span up its own like kind of like
mini
as a tree, right? It's keep growing, right? And so we've been kind of doing that on the validator side, and we also started doing this on the kind of community side. So we have this guilds program, which is really around like, if you're interested in creating a community around some topic, which is related to Near in some way, right? Like we can actually like help you and fund you and, give you tools and kind of place and everything to grow that, right? So, and ideally, like there will be meta guilds, which will spun up into a bunch of other guilds and stuff like this. Like, so that's been kind of growing. Like we have really cool create-based guild running by Mintbase, which is like about NFTs on Near, right? They just had a treasure hunt actually yesterday inside like a kind of this VR experience.
Oh yeah, I saw that. So neat. I didn't get a chance to do it. I love that connection though. NFTs to VR.
But yeah, so this is ideas like, and validators kind of have the same thing. So one of the validators like has been running Russian community for Near, and now he built already like 2 applications, right?
Cool.
On Near as well, right? So and kind of like from there, like from that Russian community, there's also like new validators spun out that actually like, kind of doing their own like ecosystem stuff and the work. So really trying to grow from there, whereas like, they educate kind of next generations, and next generation becomes like on its own kind of evangelists in the system.
Let's talk now a little bit about like to go forward on this community topic. Like, how are you incentivizing people to actually build on Near? Like, why build on Near when there's all these other L1s that we've talked about? What's the benefit? And I feel like, you guys especially have really worked on making this the developer experience. So I'm curious to hear what you say.
Yeah, so I think there is kind of few levels of this, right? So the reason why we started this, right, was because we wanted to build something ourselves in kind of this blockchain space. And we realized like how hard it is. And also, obviously like scalability being one kind of hard part, and also just building is another hard part. So we focused a lot on kind of reducing this barrier to entry. And to be honest, like we're not there yet. Like there's still a lot of work to do, right? We've solved some problems, and there's still other problems that we still identifying as we bring in more developers in and seeing kind of their feedback. But the kind of the goal, right? The aim is to make this experience really smooth for a new developer, both from existing crypto and from like open source, or even from kind of people who build software in other spaces. Like you have those great moments where people like coming from Ethereum ecosystem and say like, holy shit, this is so much easier. And like, I'm like up and running in one day and already deployed something on testnet, right? And you're like, yes, this is great. And then you have other people who come in and it's like, where is the graph? Where is the,
you don't have any tooling.
Yeah. And you're like, yes, we have like our day 0 was, November, like October 13, right? So give us some time, right? So you have this kind of like, there is still a lot of work, but we have like this early confirmation that we're on the right path. Now, so this was like a kind of basic thing. The other thing is, and this is why like this is my belief, why I believe in kind of blockchain in the first place, right? And we really like to kind of reframe this as open web, because I think actually like I saw Vitalik tweeted yesterday was like, oh, how do we rename the crypto space, right? And like, what are the names like? And the thing is like Web3 is like, it's cool for like this like geeks, but it's not really means much for people. And there's this concept of open web, which existed for 15 years. And Google, Mozilla been pushing for it like a while ago. And this is idea of really removing walled gardens. This is the idea of really like kind of enabling people to interact with web without kind of boundaries and, and centralized powers. And it's like back then when Google was kind of fighting with Microsoft, was fighting with Adobe, with Flash, with all those things, they were like pushing for it. And now when they kind of there,
they're like, let's put up a little bit of walls. But yeah. But it sounds like this is so in line with the open source community, the open source spirit, decentralization. This is super cool.
But then you go to open source people and you say like, hey, why are you guys not building on blockchain? And they were like, blockchain, isn't that like the whole scam thing that's been, in 17? And so the idea is actually bridging this gap of like open source developers who building a lot of really cool software and not getting paid for it or getting paid by big companies, and bridging this gap where we have this token economics, we have these instruments for like ownership economy, for all those things, and bringing them together. And so to do that, we have few pieces. One is on the protocol level. And so this is this contract rewards kind of economic piece that we built into protocol, where a percentage of transaction fees goes to the kind of contracts that are, serving the user, right? And so this allows, like, as you build libraries, as you build pieces like services and pieces of software on chain, they actually accrue value, like, and they can be distributed to developer, to like maybe a DAO or something. Like developer can decide how they can be distributed. But this allows to have a business model around open source.
And this is super different from what exists right now, where you have developers who will produce some sort of very, very important tool or code, like some kind of middleware. I don't know if that's the right term, but like something that will be used by other profit-making entities, but there's no way to fund it and there's no reason to maintain it. This is kind of trying to solve for that, it sounds like.
Exactly, yeah. I mean, even if you think of it like Uniswap is like originally, right, as a piece of software, didn't have a token, it didn't have an economics. Like the developer of Uniswap actually were not able to kind of take a fee even of this thing as like for regulatory reason, but like all the people with money were benefiting, right? And it's kind of like, it's very mind-boggling. And part of it is, I think, like this, I call it ownership economy, right? This whole liquidity mining and all this stuff is kind of this idea of distributing ownership of something. And so this is a very powerful concept that can be used across the whole space. The kind of this idea I've been pitching, which is like, let's imagine we're building an instant messenger and you can actually distribute tokens to people who are bringing more people into this instant messenger, right? Like, so you can leverage the same like kind of liquidity mining patterns and like distribute to people who are adding value to your network. Like to whatever network it is, instant messenger, gig economy, whatever, like a marketplace for NFTs, right? You can leverage the same patterns everywhere. So this is kind of the second layer of economics, which is, I'm writing a blog post about this, but like, I mean, obviously like this is not news. I'm just kind of trying to summarize it into like a pattern and then give like people some tools so they can do it. And so this is built on top of kind of this like open source libraries and services, which then will be accruing part of the value from there.
That sounds like something that would be really appealing to that community. Is there anything else that you've done that makes it sort of easier to build on Near?
One piece that we've started working actually way like long ago. We actually started working also last year, somewhere around this time, is a bridge to Ethereum. And our original, like from the beginning, we were like, you can do kind of a multi-sig approach where, like few people sign, but this creates such a big like vulnerability in the whole system that like we wanted something that's like trustless and decentralized from the start. So Anton, who is co-founder of 1inch, back then was working on like how to do this. And so he figured out a way kind of piecing together some work that Kyber Network did and some like kind of new stuff on our side. And we actually changed our protocol a little bit, some technical parts, right? How our blocks are organized, etc., to enable this new like rainbow bridge between Ethereum and Near in a fully trustless manner. So this thing, like it's pretty much, we actually have a private beta that's coming out. And so we had it's been running on testnet, we had security reviews, we had a hackathon with a bunch of people building on top of it. And so the idea is it allows you in a trustless manner to connect these two networks, to transfer assets, tokens, NFTs, whatever you want, and also to really do anything you want. You can call contracts on the other side. You can like prove that some piece of data exists on the other chain. Like you can actually read data from some other contracts on the other chain without even having to call a transaction on the other side. So it's very like versatile protocol. It actually works also with like other networks, like anything that has like either smart contracts or can be like programmed, like Cosmos and and Substrate networks. Like you can actually link using the same protocol. You can link to them as well. And so there's like few folks that are working with a few other chains to see how to do that. But like with Ethereum specifically, this allows the developers on Near to leverage all the kind of assets from start. For example, if you're building some new assets or new marketplaces, you can kind of leverage the like assets from Ethereum, or you can bring your assets to Ethereum and leverage the existing like exchanges, etc. So it creates this like very interoperable system.
Is this bridge, is it a mint and burn or a lock and unlock?
Well, it actually depends on what you're doing. So if so the bridge itself is actually like it's a 3-layer architecture, and so on the top like first 2 layers are providing the proving infrastructure, right? They prove that some information or something happened on the other chain. And then on the 3rd layer is, we call it application, like connector layer. And this is where you as a developer can define whatever you want. And so, for example, for token, for ERC20 to like Near's version of it, it's a lock, mint and burn, unlock kind of model. But you can also build your own, like if it's not like an existing token, but a new token that you want to deploy on both sides, it can be mint burn on both sides, or it can be whatever you want, right? You can also like
unlock on
I don't know,
both
like
sides,
you can have pools, you can have like so some people actually already working on a cross-chain pool, which like is instead of having like kind of ERC20 that you send, you're actually maintaining balances that kind of are joint balance between those two things, and you're just kind of settling underneath how things are. For example, Ampleforce, like we have a bounty with Ampleforce, and Ampleforce you cannot like just send tokens directly because the balance, the rebase can change your amounts. So you actually need to handle it a little bit differently on this connector level. And so this connector level is really where developers can go crazy and develop kind of lots of cool stuff there, including like a liquidity mining connectors that, as you deposit more funds, you maybe get like another token or stuff like this.
So you just mentioned sort of these 3 layers and that there's this proof layer. Do you know if there's a chance to put like ZKPs in that proof layer? Or do you think of using that? Or is that totally off the table?
No. It's totally on the table. It's totally like we have, I actually have a bounty. Sorry.
As the ZK podcast and ZK validator, these are the questions I need to ask.
So we have a bounty actually out for building a zero knowledge or like succinct proof for our light client. So one of the issues with Ethereum is that Ethereum it's expensive and it's actually pretty limited on how much computation you can do. Like our light client, we made it very cheap, but still costs like pretty expensive to verify all the signatures. So we actually like our light client can be succinctly proved with zero knowledge proof, and that would actually speed up the connectivity between Near and Ethereum very much. And then on top of it, any other proofs, like there's a bunch of proofs that flying around can also be like compressed with with a recursive zero knowledge proof. So yes, for sure, there's a lot of cool stuff there to do. So yeah, if anybody like on this podcast interested and excited to build something like this, reach out. We have like funding to do that, and we also can connect you to all the people in this ecosystem who are working on this.
Very cool. Well, listen, Illia, I want to say thank you so much for coming back on the show and sharing this update with us.
Yeah, thanks a lot. Thanks for supporting us as well with the Zero Knowledge Validator. And yeah, thanks for great questions.
Cool. And to our listeners, thanks for listening.